Okay, well, we are moving on to a new chapter today. Um, so your scores you might see in Pearson, but keep in mind that I also go and grade them on your test, and so the score you see in Pearson might not be the score you see in Skyward. However, it's only going to go up. It's not going to go down, so don't worry too much. The next chapter is chapter 9, and it builds a lot on what we have been doing in chapter 8. So if you struggled with something specific in chapter 8, please email me or Miss Holstad so that we can help you with that, as well as anything that you struggle with or you have questions on in this chapter. Okay, so normally we would do this top half as a warm-up, and I would like you to pause the video and kind of just give it your own tries and then check back in with the video. Okay, so hopefully you tried that. So it's first asked what point represents the golf ball before it is hit off the ground, and they're talking about this point here, which would be our y-intercept. And then what point represents the golf ball when it lands on the ground? So this point here, and that's on the x-axis, so that would be the x-intercept. And then what point represents the maximum? And as we found out in the last chapter, that's the point at the very top, which is called our vertex. So previously we've been working with quadratic functions. So here it is in standard form. And now we're going to be working with quadratic equations. And it's the same thing, except for instead of that f of x, we are now going to have it equal 0. Okay. So moving on to some examples, we're going to use our skills from last chapter and we're going to graph some. And so the first one is find the solutions of the quadratic equation. So we have x squared minus 16 equals 0. So we can find our vertex. Remember, that's negative b over 2a. Our b is 0 here, so our vertex for x is 0, and plug 0 in. To get our y value, and that would give us negative 16. So our vertex is at 0, negative 16. So our vertex would be off the graph down here somewhere. So we need to plug in some more points, or we can look at the dilation, which is 1 in this case. So it would go up 1 over 1. And then from this, it would go over 2, and then squared would be 4. So it would go 1, 2, 3, 4. But since we don't know, so this would be 1, 2, 3, 4, 5, and so on, we actually have to count by 2's. So this is negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, and negative 16. So when we go up 1, it's actually still off the graph. And then we would go 4. So since we're scaling by 2's, it would be 2, right? So over 2, up 2, 1, 2. Okay. And then if we went and did the next one, I'll show you another way to do it just in case this scaling isn't making sense to you. You could plug in your x and y values and make a table. So the next one I would plug in is 3. And if I plugged 3 in, I would do 3 squared minus 16. And that would give us 9 minus 16. Okay, so then we could plot that one. 2, 4, 6. Here is 7 right here. And we would do the same thing on the other side. So now we'll plug in 4. 4 squared minus 16. That would be 16 minus 16. So that would give us 0. So at 4 is 0. And so at negative 4 is 0. So there is our graph. Okay. So it said find the solutions though. And the solutions are going to be where it touches on the x-axis. So our solutions here are x equals negative 4 and x equals 4. In Pearson, it might make you write it like this. And it also might make you write it in coordinate form. Just know that. There's like 3 different ways you can write it. Okay, I am totally fine with this, but Pearson might make you write it like this. Okay, let's do the next one and then I'll give you some time to do the try it problems. So, we need to find our vertex. So, finding our vertex, we do negative b. So in this case now it is negative 6 over 2a. A is 1. So this gives us negative 3. Plug negative 3 in. So doing all that math, and you get 0. So we are at 1, 2, 3, 0. And then I would plug in some more points. And since I'm at negative 3 here, I'm going to go ahead and plug in negative 2 and negative 1. And so instead of this negative 3 right here, I would write negative 2 and then do the math. And if I do that, I get 1. So I could plot negative 2, 1 here. And negative 3, 1, because remember our axis of symmetry makes it reflect the same height on each side. And then negative 1 plugged in, you would get 4. So you would go up 4. So this one is a little bit easier to see what I was saying on that scaling side on this one over here. So our dilation is 1. So I first go 1 and then 1 squared would be up 1. If I go 2 over, square that, 4. 1, 2, 3, 4. Okay, so that's what I was kind of talking about on the other one. Where's our solution here? Well, just right there. Our solution would be x equals negative 3. And that would be our solution. So keeping that one, those two in mind, go ahead and pause the video and give those two a try. Okay, so if we did this one, vertex, negative b over 2 times a, negative 6 times 2 times, divided by 2 times 1, get negative 3, plug negative 3 in, we get negative 4, so our vertex is negative 3, negative 4. And then I went ahead and did up 1, and then over 2, up 4. And that led me to my x-intercepts, so my answer is right here. Again, if you have any questions, please let me know. Okay, and then this one here, our vertex, if you plug in b is 0, so 0, and then 0 squared, 0 minus 36 is negative 36. So our I scaled by 5s, so 10, 15, 20, 25, 30. And so on. So our our vertex is way down here. And then I plugged in negative 2, negative 4, and negative 6 into this equation. So negative 6 squared is 36, minus 36 is 0. Negative 4 squared, 16, minus 36, negative 20, and so on. So our x-intercepts are negative 6 and 6. So our solutions are x equals negative 6 and 6. So a key thing to remember is when it's asking for solutions, the solutions are called our zeros, which are our x-intercepts. So really important information right there. Okay, so all of our solutions were our x-intercepts, or our zeros. Again, email with any questions. So we're going to move on to the next one, which is a word problem, but same process. You're going to find the vertex. So we're going to do negative b, which is 25, over 2 times a, which is negative 5. And do that in your calculator, and you get positive 2.5. Plug 2.5 in. And you get 32.25. So our vertex is 2.5, comma 32.25. Then find your y-intercept. Which is right there, so 0, 1. And then find additional points. So since I'm at 2.5, I'm going to go ahead and do, and this is 0, so 1, and then I'm going to do 2, and then I'm going to do 3, 4, 5. And I'm just going to plug those in. Go ahead and try that. Plug these in and get those points. Plugging those in, you should have gotten this. If you didn't get this, you're probably just doing a miscalculator error. So go ahead and give it another try if you need to. Now that we have all these, I'm going to plot the points. So on my y-axis, I'm going to count by 2s. So this is actually going to be a 4. And then I'm going to mark that all the way up. And then here I'm going to go, this is 0.5, so this would be 1. So I'm going to go ahead and go out and fill that. Okay, so there's that. And now I'm going to plot the points. So my y-intercept is 0, 1, so that's right here. And then I have my vertex at 2.5, and then 32.25, and then I have my other points that I'm going to fill in. Okay, so I just plotted all those points right there, and now I'm going to draw my line as best as I can on my laptop. And then I find where my y-intercept is, or x-intercept is. 5 is 1, and if I plug in 6, it's actually in the negatives. So the ball is in the air. Just over 5 seconds. Okay, so using that, and this one is a lot nicer than that one. Use your information and try that next one. Okay, so vertex, -6 times, and then 2 times -3, 1. Plugging in 1, you get 12. So our vertex is at 1, 12. Our y-intercept is right here, the 9. So 1 up 9. Well, I know that it reflects over that vertex. So there's my axis of symmetry. So there's that one. Plug in 3, you get 0. So the ball's in the air for 3 seconds. If you have questions on that, please email me or Ms. Holstad. So we've kind of seen a little bit variety. We've seen the 1 solution up in the other example, and we've seen the 2 solutions. We also could have no solution where it doesn't touch the x-intercept. So just keep that in mind, that there's 3 types of solutions for quadratics. The no solution doesn't mean it's not a quadratic or that it can't be graphed, just means it doesn't touch the x-axis. And then 1 solution, it comes, touches, goes right back up. And 2, it touches twice. Okay, if you have any questions, please email Ms. Holstad and I. We are here for you.